Hi, in this video, we will learn about finding the inverse of a non-singular matrix using a joint matrix. What is an adjoint matrix? It is just the transpose of the cofactor matrix. Let's look at example 1. How to find the adjoint of matrix A. Remember, adjoint A is just a cofactor matrix being transposed. And what is cofactor? Cofactor is minus with the positive and negative signs. To find the adjoint matrix of A, we have to write this big bracket for the matrix. Write T here, which means we need to transpose the cofactor that we will put it in. Remember, cofactor is just the minor with the signs. Start by writing the signs first. The first sign starts with positive, and then we have negative sign, positive, negative, positive, negative, positive, negative, and positive. Remember, you have to memorize these signs. Start with the positive and then it alternates. Next, writing your minus. How to find the minor? Here, this is the first row and first column element. So to find this minor, we have to delete the first row and the first column of matrix A, and what's left is written there. Write it in these vertical bars, which means its determinant. Now, here, this is in the first row and second column. So we have to delete the first row and second column. What's left is number 3, 1, 1, and 3. So write the numbers there in the vertical bars, which means the determinant of this 2 by 2 matrix. Same for the next element. Now we are looking for the minor in the first row and third column. We have to erase the first row and third column. And what's left is number 3, 2, 1, 1. Write those numbers according to their orders in the determinant. Here, this is in the second row and first column. That means we have to delete the second row and first column to find our minor. So what's left is number 2, 3, 1, and 3. Write it in the determinant form. Next, to find this element is situated in the second row and second column. We have to delete the second row and second column. What's left is number 1, 3, 1, and 1. Write it in the determinant form. And now, this is situated in the second row and third column. That means we have to delete the second row and third column. What's left is number 1, 2, 1, and 1. Write those numbers according to their orders in the determinant form. Here, this element is situated in the third row and first column. That means we have to delete the third row and first column. What's left is number 2, 3, 2, 1. Write in the determinant form according to their orders. Now, this is located in the third row and second column. It means we have to delete the third row and second column to find the minor. The numbers is 1, 3, 3, 1. 1, 3, 3, 1. Put it in the determinant sign. And last element is situated in the third row and third column. Delete the third row and third column and you will see your minor as 1, 2, 3, 2. Put it in the determinant form and then find your determinants. How to find the determinants of a 2 by 2 matrices? Remember, it's just a butterfly. You have to use the formula AD minus BC. Do it one by one. For example, 2 times 3 is 6 minus 1 times 1. 1, put it in a bracket and then write the sign in front. Same for the next element. Put a negative sign outside and then 3 times 3 is 9 minus with 1 times 1. Next, we have 3 times 1 minus 1 times 2. Put it in a bracket and write the positive sign in front. Here, there's a negative sign outside. Make sure you put a bracket there. And then find your determinant. 2 times 3 is 6 minus with 1 times 3, which is 3. Here, the determinant is 1 times 3, which is 3, minus with 1 times 3, which is 3. The sign is positive in front. The next one is just 1 times 1, minus with 1 times 2. And there's a negative sign in front. Put the negative sign in front. Here, the determinant is 2 times 1, 2, minus with 2 times 3, 6. Put it in a bracket and the positive sign. For this determinant is just 1 times 1, 1, minus 3 times 3, 9. Put the sign in front. And here, it's just 1 times 2, you write 2 there, and then minus with 3 times 2, which is 6. Write your sign in front. Make sure you do these steps very carefully, because this is where students usually get their careless mistakes. Make sure you have the brackets there. Write your workings in the matrix like this. And then you have to simplify. 6 minus 1 is 5, 9 minus 1 is 8, and so on. Since there's a negative sign in front, it will be negative 8. Solve for the other numbers, and then you find your cofactor matrix like this. Transpose the cofactor matrix to find your adjoint matrix. How to transpose? Remember, the rows will be the columns. So 5, negative 8, 1 will be written as the column for adjoint matrix. Next, negative 3, 0, 1. And then the last row will be the last column, negative 4, 8, and negative 4. Now we would like to find the inverse by using the adjoint method. How to find the inverse of a matrix? Formula is as given. According to the formula, to find the inverse is just 1 over the determinant of A times with the adjoint matrix of A. According to the formula of A inverse, this is just 1 over the determinant of A multiplied with the adjoint matrix of A. Notice that to find A inverse, it is 1 over the determinant. Which means if the determinant is equal to 0, then you cannot divide 1 with 0. That's why the inverse matrix does not exist when the determinant or the denominator is 0. The inverse will only exist whenever the determinant is not equal to 0. Or we can also say this as A is a non-singular matrix. But if the determinant of a matrix A is 0, then we call that matrix A as a singular matrix. To find the inverse of a 2 by 2 matrix, it has its own formula. This formula comes from the adjoint matrix formula. But since it's just a 2 by 2 matrix, it's easier for you to just memorize this formula. AD minus BC is just the determinant of matrix A. And then D, negative B, negative C, and A is just the adjoint of matrix A, like we have discussed previously. Let's look at example 2. Find the inverse for matrix A. If the matrix A is 3, 1, 5, 4, how to find the inverse? Remember, we have this formula, and just use it. 1 over the determinant. So write 1 over the determinant, AD minus BC, which is 3 times 4, minus with 1 times 5. And then write the adjoint matrix following this formula. Write D first. The order of this matrix will be like this: A, B, C, D. So D is the last element. write 4 as the first element of the adjoint matrix, and then we have negative b. B is here, which is 1. So negative b is negative 1. And then A will be in the last element. Write it here, replacing the A at the adjoint matrix. Negative 1 replaces negative b. And then for C, we know it's just negative c. C is 5, so negative c is negative 5. Solve your value for determinant. 3 times 4 is 12, minus with 5, and your answer is 7. So 1 over 7 multiplied with the adjoint matrix. You can leave your answer like this, or you can also multiply the scalar 1 over 7 into the matrix. Now, how to find the inverse of a 3 by 3 matrix? Let's look at example 3. Find the inverse of matrix B. For a 3 by 3 matrix, the formula is B inverse equal to 1 over the determinant of that matrix multiplied with the adjoint of that matrix. Start by finding the determinant of matrix B. Choose the row or column with the most zeros. You can choose any row or any column to find the determinant. For example, if I want to choose the second row, because I see that there's 1 0 in second row, which will make my calculation easier. So my formula would be A21, which refers to the second row and first column, multiplied with the cofactor of that element as well. The formula will be plus with A22 times C22 plus with A23 times C23. Remember, cofactor is just the minor with the signs. So since we are looking at the second row, the sign will be in the second row of cofactor as well. We can just substitute in the values of A21. A21 is situated here. The value is 0. So 0 multiplied with any minor or any element is just equal to 0. So we don't have to bother finding what is the minor of element 21. We can just simply add the next expression. A22 is the element in the second row and second column, which is number 2. Write number 2 and then just delete the row and columns, add 2. You will see the answer is 1, 2, negative 2 and 0. Put it in the determinant form and find the determinant. So the determinant of 1, 2, negative 2, 0, AD minus BC is just 0 minus with negative 2 times 2. So here you will get negative 4 minus with negative 4. So 0 plus with 4. And then remember that A23 is the element in the second row and third column. But before that, look at the cofactor. We know that it's the cofactor at the second row and third element as well, which is a negative sign. So that's why we write a negative sign here. And then writing down the value at this element. The value is 2. Next, just delete the second row and third column. Your answer is 1, 3, negative 2, negative 1. And then finding your determinant, 1 times negative 1 is equal to negative 1 minus with negative 2 times 3. Write your working there, negative 1 plus 6, because negative means negative. And then simplify your answers. 4 times 2 is 8, and 5 times 2 is negative 10. 8 minus 10 is just negative 2. Once you have found your determinant, we have to find the adjoint. To find the adjoint matrix, it's just the cofactor being transposed. So you can start by finding the cofactor matrix of B. How to find it? Start with the signs. Positive, negative, positive, negative, positive, negative, positive, negative, positive. And then writing down the minus. Start with first row and first column. Write down the numbers. First row and second column. First row and third column. Second row and first column. Second row and second column. Second row and third column. Third row and first column. Third row, second column. And lastly, third row, third column. Once you have written all of the minus there, find the determinant of all of the minus. Remember, adjoint matrix is just the cofactor matrix being transposed. Now we just have to transpose this cofactor matrix. The rows will be the columns. 2, negative 4, 4. Negative 2, 4, 5 will be written downwards. Next we have 2, negative 2, and 2. This is your adjoint matrix. Once you have found the determinant and the adjoint of matrix B, you just have to substitute into the formula, and then that will be your inverse. Almost all of them can be divided with 2, so it's best if you multiply negative 2 into the matrix and simplify. So this will be your final answer. Okay, thank you for watching.